Hello friends, grab your coffee, grab your cookie, but today, keep both far away from any quarry conveyor because we are talking about 5 common but highly underestimated mineral dusts: limestone dust, dolomite dust, clay dust, sandstone dust, and basalt dust. These are some of the most widespread industrial dusts on Earth, appearing in mining, agriculture, construction, and aggregate processing. I am Michael Klepik, and for 15 years I have been designing air filtration and dust collection systems for quarries, cement plants, aggregate production, mineral processing, and bulk handling operations. Let's break down these 5 dusty characters. Technical description of these 5 dusts. These dusts have very different physical properties. First, limestone dust ranges from 1 micron to 50 microns and consists mostly of calcium carbonate. Bulk density ranges from 1,000 to 1,400 kilograms per cubic meter. Second, dolomite dust consists of calcium magnesium carbonate with particle sizes from 1 micron to 80 microns and density from 1,100 to 1,600 kilograms per cubic meter. Third, clay dust is extremely fine, often less than 2 microns, containing kaolinite, bentonite, or montmorillonite. Density ranges from 400 to 800 kilograms per cubic meter, and it becomes sticky when wet. Fourth, sandstone dust ranges from 2 microns to 100 microns and contains high percentages of crystalline silica. Density ranges from 1,300 to 1,700 kilograms per cubic meter. Fifth, basalt dust ranges from 1 micron to 70 microns, containing silicates, feldspar, and iron-rich minerals, with density from 1,600 to 2,000 kilograms per cubic meter. These 5 dusts differ significantly in composition, size, abrasiveness, and behavior, where these minerals generate dust. These dusts appear in many industrial operations. Limestone dust forms during crushing, screening, agricultural lime production, cement manufacturing, and quarrying. Dolomite dust appears in stone crushing, magnesium production, glass manufacturing, and steel-making flux plants. Clay dust appears in ceramic production, brick manufacturing, drying processes, bag dumping, and drilling operations. Sandstone dust forms during drilling, blasting, concrete cutting, and aggregate production with high silica exposure. Basalt dust appears in quarrying, mineral wool production, road aggregate production, and basalt fiber manufacturing. 5 materials, 5 very different industries. Why these dusts are dangerous to human health. The health risks vary. Limestone and dolomite dust are classified as nuisance dusts but can still irritate lungs and lead to chronic respiratory issues. Clay dust is extremely respirable and may contain crystalline silica, causing long-term lung irritation. Sandstone dust is highly dangerous because it contains crystalline silica, a known cause of silicosis and lung cancer. Basalt dust contains sharp silicate fragments that irritate the respiratory system and may carry crystalline silica depending on geology. Sandstone is the most dangerous due to silica content, while clay is the most respirable. Abrasion, reactivity, and material behavior. Each type behaves differently in equipment. Limestone dust is mildly abrasive and tends to cake with moisture. Dolomite dust behaves similarly, but is slightly harder and more abrasive. Clay dust is cohesive, forms deposits inside ducts, and creates bridging inside hoppers. Sandstone dust is extremely abrasive due to silica and erodes steel ducts, fans, and filter media. Basalt dust is moderately abrasive and contains iron-rich particles that accelerate wear. Sandstone and basalt are the most destructive mechanically. Behavior and airflow. From an engineering point of view, limestone and dolomite dust remain airborne easily and require steady airflow to avoid settling. Clay dust is ultra-light and travels far, clinging to surfaces, sensors, and filter media. Sandstone dust contains dense silica particles that fall out of ducts unless velocities stay high. Basalt dust behaves similarly, with heavy particles causing rapid hopper accumulation. I typically design mineral processing duct velocities between 4,000 and 6,000 feet per minute depending on material density. Best filtration equipment for these 5 dusts. Torch Air uses different collector types depending on dust characteristics. Limestone, the Blizzard standard. Baghouse works well for high-volume production. Dolomite, the Blizzard AR Baghouse with abrasion-resistant inlet baffles. Clay, the Fabrication cartridge collector with membrane cartridges to resist dust caking. Sandstone, the Blizzard silica-safe baghouse with ceramic-lined components and a HEPA final stage for silica. Basalt, the Basalt heavy-duty cartridge system or Blizzard Highwear edition for abrasive particles. 5 materials, 5 filtration strategies. OSHA and NFPA compliance requirements. Sandstone and basalt dust require compliance with OSHA's Silica Rule 29 CFR 1910.1053. Limestone and dolomite fall under nuisance dust limits but still require exposure monitoring. Clay dust must be evaluated for silica content. If present, OSHA silica rules apply across all 5 materials. First, housekeeping requirements apply to prevent dust layers. Second, HEPA filtration may be required for silica-heavy operations. Third, ductwork must be grounded. Fourth, maintenance procedures must prevent worker exposure. Fifth, dust hazard analysis is required when combustible contaminants are present. Dust collector system design. Because these dusts vary in density, abrasiveness, and cohesiveness, I designed systems specifically for each material. First, differential pressure sensors for monitoring filter loading, especially in clay and silica-heavy operations. Second, automatic hopper discharge using rotary airlocks for high-density basalt and sandstone dust. Third, super sack bulk bag collection for limestone and dolomite due to large daily volumes. Fourth, hopper vibrators or fluidizing pads for clay dust to prevent bridging. Fifth, ceramic-lined elbows and abrasion-resistant steel for sandstone and basalt. Sixth, dropout chambers for removing coarse rock dust before it reaches filters. Seventh, optional HEPA polishing stage for sandstone and clay when crystalline silica is present. This system-level design ensures reliable performance across a wide range of mineral dusts. Limestone, dolomite, clay, sandstone, and basalt dusts may seem simple because they are natural, but in industrial environments they are abrasive, respirable, and potentially hazardous. Each dust requires the correct airflow, filtration method, and safety measures to protect both workers and equipment. I am Michael Klepik. Protect your lungs, protect your equipment, and remember, minerals belong in the ground, not inside your breathing zone. See you in the next video.